This is a little experiment I'm doing to work out whether the torque of a small stepper motor has any correlation with its speed, i.e. the frequency of driving the coils. This is a little stepper motor which is geared, and I think from memory has 2048 steps per revolution. It's a 5-volt stepper motor, and it's driven by this little driver card here, which is a ULN 2003 Darlington driver. This came with the motor, and the motor and the driver board was about $5 Aussie from China. They are useful because although they're small, the gearing means they've got some torque, which is handy for small projects. So this is the board that's driving it. It looks more complicated than it needs to be, and that's because it's a board for another project. It's a board for a 4th axis rotary device for my CNC machine, which will allow me to cut gear wheels. It controls 2 stepper motors, one driven by this driver and another one which I didn't have a driver board for, so I put in the ULN 203 chip there for the other motor, which is not connected for this experiment. In order for it to communicate back and forth with the CNC machine, it has the white opto isolator chip there and another one underneath the cable there. I've 3D printed a 100mm long arm, although the absolute value of the torque doesn't really interest me, only the relative torques for different frequencies or different intervals between energizing each coil. I've reprogrammed the board for this experiment. I like to use MicroPython, and this is the IDE I use, which is Visual Studio Code, which is free and not as popular as Thonny probably, but for Raspberry Pi Picos anyway. Probably just got more facilities and you can get more extensions and things for it. And the Pico extension gives you a terminal at the bottom there that communicates with the Raspberry Pi Pico. So I've just tweaked the code there to do this quick experiment, and we'll just switch it on. So it defaults to 10 milliseconds per step, and I'll just bring it down to say 8 milliseconds per step. I'll turn on the little scale here, change it to grams, then start the routine, and it just brings the arm up and down, and I measure 44 grams for that impact. Then it will bring the arm up again, and it will press it down again, 42 grams, and it will do this 5 times. I take a sort of average reading. I would take 42 for that, and I've done the same for all the different intervals from 10 milliseconds down to 2 milliseconds. After 5 it'll just stop and it'll retract the arm. Okay, so interestingly, these are my results. For 10 milliseconds it was 42 and 9, and I actually got 47 for 8, although it's a little bit less this time that I'm running it. At 5 milliseconds it went right down to 24, but then at 3 milliseconds it went up to 46. 1 millisecond was too fast for the motor. So it's interesting that the 5 milliseconds and the 3 milliseconds are so different. I reran them and those results do seem correct. I did notice that the sound of the coils was very different between 5 and 3. 5 sounded more like a vibration, whereas 3 sounded a lot smoother. And I assume that the good result for 3 milliseconds is due to the perhaps inductance of the coil and resonance of the coils or whatever. But I shall certainly be proceeding in future at programming these particular stepper motors at 3 milliseconds and see how we go. Previously I had them a default of 10, and it looks as if we can get a similar torque 3 times as fast with the 3 reading. I've not tried different motors. Obviously I've got a number of these, I could swap them in, but for now that's what I'll go with to proceed with the project for the CNC 4th axis. It might be good to just tune it a bit more and have a look at the readings between 2 and 4, find if there's even better sweet spot around 3. But for now, that's been quite an interesting result, I think. If you've got any comments, I'd appreciate them. Thank you.